Shalom to you. More problems on right triangle application. Trig. Again, involving right triangles and angles of elevation and depression and bearing. So one problem quickly. A pilot is traveling on a course of 36 degrees. So that's the course of 36 degrees. So let's pick a point for a pilot. So this is where the pilot is. We draw our north, south, east, west pole. And the course it made here is 36, so which will be about here. So this angle here is 36 degrees. And it says, and the site, okay, that's the line of travel. And sights an airport. So, okay, the pilot's line of sight forms a right angle with the travel. So this is line of travel. So this is travel. So perpendicular. So anything perpendicular is going to be 90 degrees. So of course we can assume it's going to be on this side because this will be behind, kind of looking backward. That would be hard. So it looks like right angle here. Perpendicular. So the airport is here. Okay, so of course on the airport we still have the coordinate there. Okay, so it says find the bearing of the airport. Okay, now the common mistake with people finding the angle at the airport here. We say find the bearing of the airport. Whenever you hear bearing, ask from where. From is the origin of that bearing. That's where the angle will form. Bearing of the airport from where? And of course, we have only one point here from the pilot's line of from the pilot, where the pilot is, which is this point here. So the angle of the bearing of the airport is going to be the bearing that is angle that is formed at this side. Let me draw that with a different color. So again, it's going to start from the north and it's going to go to this line of sight. Again, this is the line of sight. So that's the angle we are looking for. Well, what do we know? We know that this angle here is 90 degrees. The angle in black is 90 degrees. And part of it is 36. So let's find this remaining part here. 90 minus 36. Okay, yeah. 90 minus 36, which is 54. So this angle here is 54. Okay, so now to find the angle, the bearing, the blue one, it's going to be 360 minus 54. Which is 306. And that's it. Right, next, an airplane is flying at 60 miles per hour and he flew for 1.4 hours. So let's find the distance, which is rate times time. So the distance is 600 times 1.5 hour, which is 900 miles. Okay, so this is the pick a point for the airplane. Then that's north, south, east, west. The bearing is 52. So if it's 52, so it's going to be about here, a little after 40, 52 degrees. And so the distance it traveled on this line is going to be that 900 miles so far. Then it's asking how far north and how far east. How far north and how far east. Let's use N for north. So if kind of make an arbitrary point here. How far north? This is east and this is north. So we are looking for this length from here to here. And of course, the north and east are going to make a right angle there. So do we have enough information? We have the angle, we have hypotenuse. So yes, we can use SOHCAHTOA to find that. So sine 52 is opposite the angle is E over hypotenuse, which is 900. So E is going to equal cross multiply 900 times sine 52, which is about 7 over 9.2. Okay, mile. Okay, that's the east. Then the north, so what we have, that is adjacent. So it's going to be cosine 52 is adjacent over hypotenuse. So cross multiply, and it's going to be 900 times cosine 52. And that will be about 4.095, which is about 554.1. Okay, that will be the distance it has traveled north. Another one. A ship leaves port and travels 30 miles due north. Okay, so it starts from here. And of course, we have the north, south, east, west. So it travels from here, travels due north, It's here for 30 miles. And then it changes course. So we're going to have a point there because the north continues west, south, east. And then from here it go to northeast. So northeast 15. Okay, I'm going to change color here. 15, tiny bit. So this angle here is 15. And of course, we can extend this. 15 degrees. Travels there east and travels 10 miles on it. Find the ship's bearing from the port of departure. So the port of departure is right here. So we are looking for this port of departure. Okay, so we have several, this is not a right angle here, so for sure. So we have to find a way, do certain other background work, okay? So we can, of course, close this here. Our imaginary line always there. So we can have a right angle there. And let's call this X. And we can call this Y. Well, we know from the departure to this point, he travels 30. But this other part, we don't know. But here we have a right angle. At least here, let's use it. We know this side to find this X and Y to start with. Okay. Alright, so we can have sine 15 is opposite, which is X, over hypotenuse, which is 10. So X is going to be 10 times sine 15, which is 2.588. Yeah. Okay, we do the same thing for Y. So you got going to be adjacent. So cosine. So cosine 15 is adjacent over hypotenuse. So Y is going to be 10 times cosine 15, which is 9.659. Okay, so we have this length now. We have this Y, this length now. We know what it is. So that's 9.659 and we know this side x also. So therefore we have a right angle here. Let's do red now. So you see this, there's one big angle, not right angle here with this line we are looking for. So we can use Pythagorean theorem, but also because these numbers are already rounded, I encourage you to use SOHCAHTOA, because if we have this side x, we can also find this angle right here. Okay. So because we are looking for the bearing, if we are looking for the bearing, we are looking for the angle, not the side, this angle here. So not mainly the side. So the SOHCAHTOA will be helpful. So if we call it theta, so we know the side opposite it now, and we know the adjacent of it, because if we add those two numbers together, that gives us that. So therefore, tan theta is opposite, which is that x. X is 2.588. Adjacent, which is adding 30 and that 9, that's 39, which is 39.659. So theta is going to be, is going to be the inverse tan of that. So we can plug it into our calculator like that. We get about 3.7. It's a little tiny angle, and it would be. Okay. Hope you get that. Thank you for learning.